This video is about the synthetic division of polynomials. We did long division, now we're doing synthetic. Alright, so this is the form of the polynomial that you're used to. A times x to the cubed, bx squared, cx to the first, and then a constant d. Basically all your powers of x are in order, and it's subtracted by a linear equation. Notice x is to the first power. That is essential to be able to use synthetic. If it's squared or something else, you can't use synthetic division. So the way this will look is you're going to set up a division problem, and it looks like this. The k back here is going to switch the sign. So what was negative in the equation becomes positive here. And then what you're going to do is write the coefficients in order, in exponent order. So it'll go A, B, C, D. You draw a line leaving some space there. And what's going to happen is you're going to bring down A. And you multiply A times K. And then you combine them straight down. You combine like terms. Whatever you get here, you multiply it by K. Multiply by K, and then you're going to put that here. Combine like terms, multiply by K, combine here, and bring it down. And whatever you have here would be your remainder. Okay? And then whatever, we'll talk about the power of x that would go with your answer here in a minute when we do an example. But here's the things you really make sure you need to do. The k in the problem, the sign has to be reversed from the original. The divisor must be linear, just like we said here. Whatever you're dividing by has to be x to the first power. The terms have to go in exponent order. Just like with long division, if you're missing a power of x, then you have to put a 0 in. Alright, let's try one. Alright, look at this one. X to the fourth, x squared, x to the first. So I don't have any x to the third term, so I need to put a 0x cubed in there. So I'm going to set up my problem. Remember, I have to change the sign of k, so this is going to be a negative 3. And then I put my exponents in order. It'll go 1, 0, negative 10, negative 2, and a 4. Okay, I'm going to draw my line, and I'm going to bring the first number down, 1. 1 times negative 3 is negative 3. Combine like terms, 0 minus 3 is negative 3. Negative 3 times negative 3 is a positive 9. Combine like terms, negative 10 plus 9 is a negative 1. Negative 1 times negative 3 is a positive 3. Negative 2 plus 3 is a 1. 1 times negative 3 is negative 3. Combine like terms, and I get a 1. So whatever you end up over here, this is your remainder. Okay? So in order to write your answer accurately, it needs to be written in polynomial form. So you look back at the original equation. Look at the highest power of x here. That's a 4. So my answer is going to be 1 power less. So this is going to be x cubed. This will be x squared. This will be x. And then this is a constant. So if it's positive, that's a plus. So my answer, the remainder, just like before, is going to go over the divisor. So my full answer is going to be x cubed minus 3x squared minus x plus 1 over x plus 3. Okay, remember the remainder goes over the divisor in your answer. So all of that is my solution that I got to it through synthetic division. Let's try another one. Get your powers of x. I have 3, 2, 1, 0. So powers are all covered. Here's my k. To set up my problem, I'm going to do negative k, and then the coefficients, 5, 8, negative 1, and 6. Okay, same problem. Bring this down. 5 times negative 2, negative 10. 8 minus 10 is negative 2. Negative 2 times negative 2 is a positive 4. Negative 1 plus 4 is a 3. 3 times negative 2, negative 6. So I have a 0 for the remainder. To finish it off, I need my powers of x. It started with x cubed, so I go 1 power less. X squared, x, and then no x over here. So this is my constant. So my final answer is 5x squared minus 2x plus 3. Some people like synthetic a lot better because it's faster. Some people don't. Make sure you just follow all the correct steps. Okay, then there's something called the remainder theorem, and it says this: you can use synthetic division to evaluate a polynomial function. The remainder will be your answer. So let's just say I gave you this equation, and I wanted you to find f of -2. So you would plug in -2 for x. You could go through all the math here, cube the -2, multiply by 3, yada yada, all of that, or you can just do synthetic division, and you'll get your answer. Some people think it's quicker, so let me show you. So if I set up my table, now this is the different thing with remainder theorem. This isn't necessarily your k that you have to switch the sign of. You don't switch the sign if you're doing this. Don't change the sign if you're using remainder theorem, because you're plugging in the exact value of x they're giving you. It's not written as a factor, that's why. So now, powers of x are covered, 3, 2, 1. So we go 3, 8, 5, -7. And we're going to work through the process. So bring the 3 down. 3 times -2 is -6. 8 minus 6 is 2. 2 times -2 is -4. 5 minus 4 is 1. 1 times -2 is -2. And this gives me -9. So if I had evaluated this function, if I had taken the time to put a -2 cubed, -2 squared, -2 here, finished it off old school, my solution would have been -9. That is my answer. So f of -2 equals -9. It is a shortcut. It's called the remainder theorem. Okay, so use it accordingly. Okay, on the whisk, you're going to use the synthetic division to evaluate that. So plug in a 4. If you plugged in a 4 in for x, what would you get? Use synthetic division to find your answer. All right, try that. Remember, don't change the sign of the 4, but make sure all the powers of x are represented. So in your whisk, you're going to tell me what is the solution to this when you evaluate it at f equals 4.